morning, my dear students. Already ICSE exam has started, and your maths exam is going to be occur within 3 to 4 days. तो अगर आपको मैथ्स में फुल मार्क्स प्राप्त करना है तो सर्कल चैप्टर जानना बहुत ही ज़रूरी है। यूँ कि आप देखते हो कि कोई कहता है कि पेपर लीक हो चुका है, ये सब बकवास की बात है। बस आपको कॉन्सेप्ट की बहुत ज़रूरत है और धैर्य से एग्जाम लिखिए, फिर मार्क्स 80 आउट ऑफ 80 इज योर्स। सर्कल चैप्टर जानने से पहले यूं कि हमको पता है कि थ्योरम आपको आती नहीं है प्रूफ करने के लिए, लेकिन ये थ्योरम जानना जरूरी है क्योंकि सर्कल चैप्टर का जो बेस्ड क्वेश्चंस है ये एंगल्स के ऊपर है, टेंजेंट्स के ऊपर है, सो यू मस्ट नो इट। सो लेट अस ड्रॉ अ क्विक रिवीजन from the circle chapter, and we are having 14 theorems. In this video I will be showing you that how the 14 theorems can be proved simultaneously, making you sure to get full marks from the part of the circle chapter. The very first question, that is the very first theorem from the 14th theorem, is a straight line drawn from the center of a circle. Let us draw a circle over here. This is a center O. To the bisect a chord, let us say this is a chord AB. That means what? From this theorem there is saying that a straight line is drawn, let it meet at C, then this bisect this, that means what? AC equals to CB, they have said. Now what we have to see, which is not a diameter. See, AB is not a diameter because if it is diameter it will pass from the center, is at right angles to the chord. That means what? We have to show that this angle is 90 degrees. So how we can show it this one? First let us join this. This becomes the radius. Let us join this. This becomes the radius. Now from this diagram you can see that this is a triangle OAC and this is another triangle OCB. In these two triangles OA equals to OB, we can very well write on O equals to OB. Reason, it is the radius. Next, AC equals to CB, because already we have done here, it is given in the theorem, that is AC equals to CB, it is given. Next, OC is the common, so OC equals to OC, which is a common side. So by SSS, the two triangles are congruent. From here we can say that the two triangles are congruent. That means what? This angle must be equals to this angle OI, CP, CT. Let this angle be X, then this angle is also X, then we get X plus X equals to 180 degree. Why? This is a linear angle. That is 2x equals to 180 degree, that means x equals to 90 degree. So hence the theorem is proved. एक और theorem number 2. The perpendicular to a chord from the center of a circle bisects the chord. You have to say that it must bisect the chord. इसका मतलब क्या है? ये आपका सर्कल बनता है, ये सेंटर है O, एक कोई भी एक chord है AB. अब यहाँ से कोई भी हम परपेंडिकुलर खींचेंगे, या तो ये 90 है, ये 90 डिग्री है जो कि देख दिया हुआ है. Let this point be equals to C. Now you join this to this one. So this is radius, this is radius. Very simple. ध्यान से देखिए, OAC एक ट्राइंगल है, OCB एक और ट्राइंगल है. इन ट्राइंगल में this side equals to this side. Why? Because they are the radius of the circle. This is the common side for this two triangle and this is 90 degree they have given in the question. So by RHS, that is right angle, hypotenuse and side, these two triangles are congruent. Since these two triangles are congruent, that means what? AC equals to CB. Why? CP, CT. When two triangles are congruent, then corresponding parts of congruent triangles are always equal. So you must know this theorem as well. एक और थ्योरम है, थ्योरम नंबर 3. इसमें बताया गया है कि there is one circle and only one circle which passes through 3 given points. 3 पॉइंट्स है जहां से पास किया जाता है, एक ही सर्कल पास करेगा which is not in a line, यानी कि वो 3 पॉइंट्स लाइन में नहीं है. तो ले लेते हैं 3 पॉइंट. एक पॉइंट है, सपोज एक पॉइंट है और एक पॉइंट है, तो हमको दिखाना है कि इन तीनों पॉइंट से सिर्फ एक ही सर्कल जा सकता है. तो चलो ये पॉइंट को हम A पकड़ लेते हैं, B पकड़ लेते हैं और ये C, जो तीनों पॉइंट एक लाइन पर नहीं है. तो पहले सबसे पहले हम इसे ज्वाइन करेंगे इस तरह से और इसे इस तरह से हम ज्वाइन करेंगे. ज्वाइन करने के बाद फर्स्ट वी विल ट्राई टू फाइंड आउट द परपेंडिकुलर बाइसेक्टर ऑफ AB. सो विद द हेल्प ऑफ द कंपास वी ड्रॉ अ परपेंडिकुलर बाइसेक्टर like this and somewhere like this. So perpendicular bisector means it will pass through the midpoint. Let us say it is as O. Next, again we have to draw a perpendicular bisector from this AC BC with the help of compass. So we can find out the perpendicular bisector which will pass in this way. Let us say as O dash. That means what? Here AO equals to OB. Since AO equals to OB, since this is a perpendicular bisector, that means what? Let it be say as P. Then AP must be equals to PB. AP equals to PB, and similarly PB equals to PC. PB equals to PC. So from these two statements we get AP equals to PB equals to PC, means all these distance are same. Now with the help of this we can construct a circle in this way, being P is the center. So our theorem gets proved in this way. अब हम थ्योरम नंबर 4 में आ जा रहे हैं. वेरी इंपॉर्टेंट थ्योरम इट इज. थ्योरम नंबर 4 बता रहा है कि इक्वल कॉर्ड्स ऑफ अ सर्कल. चलो एक सर्कल ड्रॉ कर लेते हैं यहाँ पर विद सेंटर O. अब बता है कि इक्वल कॉर्ड्स, लेट दिस बी AB and this be CD. Now they said that AB equals to CD. Equal chords they have already said are equidistant from the center. That means what? If you draw a perpendicular from here, let it be P, and here let it be Q, then what you have to prove that OQ equals to OP. This we have to prove. So to prove this, first what we'll do, let us join OB and OC. Now we can see that since AB equals to CD, it is given, and more this is the perpendicular distance. So we have already learnt that a perpendicular bisects the chord. That means what? AQ equals to QB, PD equals to PC. Since these two chords are same, therefore QB equals to PC. Number 1. Number 2 is that this is the radius, this is the radius. So both the radius of the same circles are equal. And number 3 is that this is right angle. Already we have shown that. Let us construct a perpendicular from here. This is also perpendicular. That means what? We have already proved that this equals to this. This is the radius of the two triangles. This is right angle triangle. So hence by RHS axiom the two triangles are congruent. Since the two triangles are congruent, therefore corresponding parts are equal. That means what? OQ equals to OP, which is CP/CT. That is corresponding parts of congruent triangles are always equal. Hence this theorem gets proved. ये थ्योरम नंबर 5 है. एक और इम्पोर्टेंट थ्योरम है, बहुत ही महत्वपूर्ण थ्योरम है, ध्यान से देखिएगा. थ्योरम कह रहा है कि chords of a circle equals distance from the center of a circle are equal. That means what? Let us draw a circle like this. This is the sector O. Let the chords be AB and this is CD. Now they have said the chords of a circle equidistant from the center. That means what? From this center, let us join as a P. This is a perpendicular. Let us join it as Q. This is perpendicular. That means what? We have given that OP equals to OQ, which is perpendicular to this. Now we have to prove that AB equals to CD. To prove, we have to prove this. So first let us join OB and OD. So from this we can say that since this equals to this of these two triangles, this is 90 degree and this is the radius of the two triangles are equal. Therefore by RHS axiom these two triangles are congruent. Since these two triangles are congruent, therefore PB must be equals to QD. So we know this point, and also we know that any line which passes through the center and perpendicular to any chord bisects the chord. Already we have learned this theorem. So PB equals to AP and this equals to this. So from here we can say that PB equals to half of AB and also QD equals to half of CD. So from this two we get half of AB equals to half of CD. This gets cancelled off. AB equals to CD, which is being proved for this theorem. Thank you. यह थ्योरम बहुत ही इंपॉर्टेंट थ्योरम है। आईसीएसई के एग्जाम में, हर आईसीएसई के एग्जाम में करीबन 2 मार्क्स का तो क्वेश्चन बनता ही है इस थ्योरम के ऊपर। सो ध्यान से सुनिए यह थ्योरम किस तरह से प्रूफ किया जाता है। चलो पहले पढ़ लेते हैं कि थ्योरम क्या कह रहा है। The angle which an arc of a circle, so let us draw a circle first with center O. Arc means let us consider here A, let us consider here as B. So AB becomes an arc. At the center, that means what? This arc is making certain angle at the center. So this angle is angle AOB. Angle AOB is the arc subtended at the center of the circle. Is double, यानी कि ये एंगल डबल होता है। किसका डबल होता है? Which it subtends at any point. It subtends मतलब ये आर्क कोई भी एक पॉइंट सबटेंड कर रहा हो, शायद ये पॉइंट बन सकता है, ये बन सकता है, यहाँ बन सकता है, कुछ कहीं पर भी बन सकता है। तो चलो हम एक पॉइंट हम ले लेते हैं यहाँ पर। Okay, or we consider this point over somewhere here. Let us consider point here A, B, C. Now we have to join this point. This arc is subtending this angle at the center and at C this angle. Now we have to prove that angle AOB is equals to twice of angle ACB. So for this, इससे करने के लिए हम कैसे करेंगे? सबसे पहले हम CO को ज्वाइन करेंगे इस तरह से। अब CO जब ज्वाइन हो जाता है, so this is the radius, this is the radius. Since then this triangle becomes an isosceles triangle, let this angle be x degree. So this angle is also x degree. And also we know that this is the exterior angle. Let this angle 1 be the exterior angle, this point. So angle 1 is equals to sum of the interior opposite angles. That is angle 1 equals to x plus x equals to 2x. So angle 1 equals to 2x. Now let us try and go with this triangle. Since this equals to this, so this becomes an isosceles triangle. So this be y, then this is also y. Let this angle represent to be angle 2, this angle 2. So this is an exterior angle of this triangle. So angle 2 equals to 2y. Y plus y equals to 2y. Now if we add this, angle 1 plus angle 2 equals to 2x plus y. But x plus y is this angle, that is angle ACB equals to 2 angle ACB, and angle 1 plus angle 2 is angle AOB. Hence this proves this theorem. Thank you. One more important theorem. This is theorem number 7 out of the theorem number 14. Angles in the same segment of circle are equal. That means what? Suppose if this is a circle with center O, then this is arc AB, that is angle ADB and angle ACB are the angles in the same segment. That means what? We have to prove that these two are equal. So what we will do? First we will join this. Just now we have read in the previous theorem, that is angle AOB equals to twice of angle ADB. Also angle AOB equals to twice of angle ACB. So from this two we get that angle ADB equals to angle ACB. This proves our theorem. This is theorem number 8. The angle in a semicircle is a right angle. Is also one of the very important theorem. So this is based on the previous theorem only. It's very simple. So let us draw a circle. This is center O. The angle in a semicircle. This is semicircle. Let us go with AB. At any point, let us say as C. Then join this and this. We have to prove that angle ACB equals to 90. We know that angle AOB, angle subtended by the arc AB, is 180 degree. Angle AOB equals to 180 degree. And also we divide because it is a straight angle. Angle AOB is a straight angle. And also we know that angle AOB equals to twice of angle ACB. Angle subtended at the center is double the angle subtended at any point on the circumference. So from this two we get angle ACB equals to 180 by 2, which is equals to 90 degree. One more theorem, theorem number 9. The opposite angles of a cyclic quadrilateral. So what is cyclic quadrilateral? Let us first draw a circle in this way. This is center O. Let us take A, B, C, D. So this becomes a cyclic quadrilateral ABCD. So ABCD is a cyclic quadrilateral. Are supplementary. That means what? We have to prove that this plus this equals to 180 degree. Automatically this plus this also becomes 180 degree. So we have to prove that angle ABC plus angle ADC equals to 180 degree. चलो इसको प्रूव करने से पहले क्या करेंगे? सबसे पहले AO को ज्वाइन करेंगे, OC को ज्वाइन करेंगे. अब देखिए AC एक आर्क बनता है. So this angle AOC equals to twice of angle ADC. Just now we have gone through the previous theorem that the angle subtended by any arc at the center is twice the angle subtended at any other point on the circumference. Now similarly, angle ABC, this is the reflex angle of angle AOC. So we also know that reflex of angle AOC means this angle equals to twice of angle ABC, the same theorem. Now if we add these two, just add it like this. So the angle this plus this becomes a whole complete angle that becomes 360 degree equals to twice of angle ADC plus angle ABC. If you cut it like this, it becomes 180 degree, for which our theorems gets proved. My dear students, I hope you are all understanding properly as I have said. शुरू करते हैं theorem number 10. The exterior angle of a cyclic quadrilateral is equals to the interior opposite angle. तो इसका आपका डायग्राम बनता है. पहले इस तरह से आप सर्कल का डायग्राम बना लीजिए. ये सेंटर O बन जाता है. This is A, this is B, this is C, and let us take as D. Now let us join this. Now let us extend BC straight away. Let us take as point E. So what they have said, क्या बताया है यहाँ पर? The exterior angle of a cyclic quadrilateral. So this becomes the exterior angle. is equal to the interior opposite angle. That means what? Angle DCE, we have to show that this angle must be equals to angle DAB. This is very easy. Try to understand it very carefully. We know that ABCD is a cyclic quadrilateral. We know that this angle plus this angle must be equals to 180 degree. Just now the previous theorem we have already learned in the theorem that in the cyclic quadrilateral the opposite sum of the opposite angles are 180 degree. That means what? Angle DAB plus angle BCD equals to 180 degree. Also angle BCD plus angle DCE equals to 180 degree, because this is from the theorem and this is the straight angle, supplementary angle. From this two we get that angle DAB plus angle BCD equals to angle BCD plus angle DCE. Now this gets cancelled, so angle DAB, this angle plus is equals to angle DCE. This theorem is proved. This is theorem number 11. In equal circles, let the circles be in this way. This is circle C1 with center O, and this is circle C2 with circle O dash. If two arcs subtends equal angles, let arc here AB, this angle equals to CD, this angle at the center, they are equal. If two, that means we have to show that arc AB is equals to arc CD. Here what you have to do is, if you place this circle on this, we know that the circles are equal, therefore this radius and this radius are same, this radius and this radius same, and this angle is equals to this angle is same. If you place this on this and the angle are same, we can see that OB coincides with O dash D. Hence the first theorem gets proved. Next, in the second theorem it is given that in equal circles, circles C1 and C2 are equal if two arcs are equal. So this arc and this arc AB equals to arc CD. Then this subtends equal angle at the center. Again you place this circle on this circle, then we can find out that CD coincides with this, OA coincides with this, OB coincides with O dash D, and finally this angle becomes this angle. In this way the two triangles, the two theorems can be proved theoretically and practically as well. One more theorem, that is theorem number 13. In equal circles, if two chords are equal, let us suppose that this is a circle 1 with center O, this is circle 2 with center O dash. These two circles are equal. Now they cut off equal arcs. If two chords are equal, let us say the chord AB, CD. Now AB equals to CD given. Let us join this OA, this, join this, join this. Now from these two triangles, OA equals to O dash C. Why? Because the same radius are same, and because the circles are equal. Again this side equals to this side, same radius. Again AB equals to CD, it is given. So by SSS theorem, these two triangles are congruent. Since the two triangles are congruent, therefore this angle equals to this angle, that is angle AOB equals to angle CO dash D. Now the previous theorem we have learned, when in the equal circles, when the angles subtended by the equal chords at the center, then the arcs are equal. That means arc AB equals to arc CD, which our theorem gets proved. This is the last theorem of the first part of the circle, which you must also know. The theorem says that in equal circle, if two arcs are equal, so let us take two circles which are equal with center O and O dash. So C1 and C2, two circles with are equal circles. In equal circles, if two arcs are equal, let us say this is A, this is B, this is C, this is D. Now AB is equals to CD. Then we have to prove that the chords of the arcs, that means what? We have to prove that AB equals to CD. We have to prove this. So first what we will do is, let us join this. Now the angle subtended by the arc AB is this angle is equals to the angle subtended by the arc CD is equals to this angle. The reason behind that is the two triangles are equal. The two triangles are equal and the two arcs are same, so they will subtend equal angles at the center. Now considering the triangle OAB and O dash CD, OA equals to OC. Why? Because both are the same, having the same radius. This equals to this, again same radius. So by SAS, these two triangles are congruent. Since that these two triangles are congruent, therefore AB equals to CD, that is CPCT, congruent parts of congruent triangles. So with this, our first part of the circle, the theorem gets completed, my dear students. So you must be well prepared with these theorems, because obviously through these theorems you are going to get few problems in your ICSE exams as well. Thank you.